Now let's do problem 1. It's not going to be a difficult one. Ike and Mike go into a sandwich shop with a total of $30 to spend. Sandwiches cost $4.50 each, and soft drinks cost $1 each. Okay. Ike and Mike plan to buy as many sandwiches as they can, so we want this to be maximized, and use any remaining money to buy soft drinks. Okay. So some people will want to write like this, right? You would go 30 and they want to divide 30 by 4.5. Is that a good idea? It works, okay, because the last number you could write here is going to be 6, but it's a bad idea, right? If you do this for question 1, you waste time and then you get nervous. Okay, but the question is way easier than doing this. Now you just guess how many sandwiches. For example, 10, right? So 10 sandwiches would be like what? 4.5, 45. It's too much. So fewer sandwiches. What is the next number? You decide. So here, remember 2 sandwiches are 9. Okay. So let's start with this. So 4 sandwiches will be double of this, would be 18. 6 sandwiches will be, okay, 27. And can we buy one more sandwich? We can buy 6. If we buy one more, it's going to be 27 plus 4.5. It's going to be more than 30. So the answer is no, we can't buy any more sandwiches. So 6 is the biggest number. Good. So now 27, 30. How much money is left? 30 minus 27. We have $3 left. Okay, how many soft drinks we can buy? Each one is 1. 3 soft drinks. Okay, so how many items in total, right? So we have 6 sandwiches, 3 soft drinks. Okay, so it will be a total of 9. 6 plus 3 is equal to 9. So D would be the right choice for problem 1. Okay. Okay, problem 2. 3 identical rectangles are put together to form rectangle ABCD. Okay, identical means these 3 smaller ones, all of them are the same and equal in every way. Okay, so what does that mean? That means, okay, this line, let's highlight all the ones that are equal, right? These are all the same because they are all identical. Good. This is what we know. Given that the length of the shorter side of each of the smaller rectangles is 5 feet, what is the area in the square feet of rectangle ABCD? So this is 5, this is 5, this is 5, and this is 5. Now, what is the length of the large side now? This one will be 10, 5 plus 5. So that means this is 10. That means this is 10. That means this is 10. That means this is also 10. So we want the big rectangles area. This side is 10. This side is, remember the blue one was also 10, right? 10 plus 5, 15. So what is the area? 10 times 15 is equal to, let me write it down so that my explanation is complete. It's going to be 150. So E is the right choice. Okay, problem 3 could be very easy or very tricky depending on how you look at it. So if somebody tells me that I wasted a lot of time on this question, I would believe them. So which of the following is the correct order of fractions that you see them from least to greatest? Okay, so what is the general way of doing it, right? So if these numbers have no pattern, One way would be doing it like this. So you go, okay, 15 divided by 11. You just divide them. It's going to be here 1. Okay, minus 11. It's going to be 4. Okay, so 0, point here, 40 is going to be 3. 33. So it would be like 70, and you would go on like this. So you do this for all the 3. You turn them all into decimals, and then you could easily compare. Okay, this is the general way. Okay, does it work? 100%. Is it the best way? No, it's a waste of time. So, but why is that a waste of time? Because if you look at these fractions, you see that there's always something going on. The top number, the numerator, is always 4 more than the denominator. So what does that mean? 11 plus 4 is 15. 15 plus 4 is 19. 13 plus 4 is 17. Okay, so that's the pattern. Now, how can we use that? Remember, we could write, I'm going to just do the first one. 15, we could write it as 11 plus 4. Right, isn't it? Over 11. So if I write it in terms of mixed number, I could also write this way, 11 over 11 plus 4 over 11. Okay, so what is 11 over 11? That's clearly 1. So this one is actually 1 over 411. Okay, you don't like this way? However you know, however you're comfortable, however you learned at school, just turn this into a mixed number like that. Okay, you don't have to follow my way. Okay, so if you do that for all of them, the next one, okay, will be 1, this one. 19 over 15 will be, okay, 1, 4 over 15. Okay, and the last one you tell me is 1, 4 over 13. Good. So we just want to compare them, right? So you could see clearly that 1 is equal to all of them. So you just have to compare these ones. 4 over 11, 4 over 13, 4 over 15. Okay, which one is the smallest one? Okay, so the smallest one would be this. Why? You could imagine like this, right? This might help. Imagine you have 4 pizzas and you want to divide them among 15 people. Okay, so here you have 4 pizzas and you want to divide them among 11 people. So everybody will have more at this. This one, you have 4 pizzas, the last one. You want to divide them among 13 people, right? So when you divide it with more people, it would be less. So this will be the least amount. And which one, guess what? Which one is the most? Okay. This one, okay, 4 over 11, because 11 is the smallest number. You're dividing it among fewer people. So this will be the greatest. Okay, so which one is like that? Okay. Which one says from least to greatest? Okay, this is the greatest. This one was 15 over 11, right? This is 15 over 11. Okay, and 19 over 15 is the smallest one. So we just have to pick E. Okay. Now, we could use this problem as a learning opportunity like this. See, now, each of these fractions are in these terms, right? It was like 11 plus 4 over 11, right? So instead of 11, we could put any number. So I'm going to write it like this. Now tell me, as a increases, getting larger and larger, what happens to the fraction? So for example, if I, instead of a, if I put 1, what happens? If a is 1, what do I get? I get 5 over 1, 5. You see, the fraction is rather large. Now let's go put 2 in it. It will be 6 over 2, 3. So 5 turned into 3. Okay, now instead of 2, if I put 3, what happens? It's going to be 7 over 3. You would see that as a is increasing, okay, this will get smaller and smaller. And what is the greatest number you know? So for example, if we have a plus 4 over a, and imagine a is infinitely large. So 9999999 forever. So what happens here? The answer would be close to 1. So we're right, the answer would be 1. When a is extremely large, this fraction turns into 1. Okay? So I hope you found this extra point helpful. Well, for problem 4, I've had students who were so good, they would like do question 20 plus, even 25, but they had problems with this question. And let's read it and I'll tell you why. So quadrilateral ABCD is a rhombus with a perimeter 52 meters. The length of diagonal AC is 12 meters. What is the area in square meters of rhombus ABCD? Okay, so one thing, perimeter is what? Perimeter is all of this. Okay. It has 4 equal sides, edges. So 52 divided by 4 is actually 13. Now, what I told my student who couldn't do this, when you see these numbers, right? So you have to think of Pythagorean theorem, right? So especially when you see, okay, this is 13, AC divided by 2, which is going to be this one. AC divided by 2 is this one. You hear 12, you hear 13, Pythagorean theorem. Okay, so because this is a popular one, okay, if this is 12, this is 13, should have this memorized. This is 5 already. Okay, let's assume that you didn't know this, right? But it's still okay. So let's call this one, the middle one, this part, question mark. So question mark squared plus 12 squared is equal to 13 squared. This is 169. This is 144. So question mark squared is equal to 169 minus 144 is 25. So question mark is 5. There you go. Okay, that's it. So now we have the sides. So how do we find the area of this rhombus? One way, the safest way, is to find this area and multiply by 4. It would be like easier. Since we have this one, this would be another one like this, 2, 3 of this, and 4 of this. So we find the area of the purple one, the purple triangle, we multiply by 4. So what is the area of the purple one? 5 times 12 divided by 2. 1 will be canceled with 12, like this will cancel. 5 times 6 is 30. So the purple triangle is 30. We have 4 of that. So we're going to have 30 times 4, which is going to be equal to 120, which results in choice D. Now, if you don't understand problem 5, I know why. Just listen to me. See, imagine we have a tortoise, okay? The tortoise is not moving. It's just sleeping at position 3, okay, at this position for 1 hour. Can you draw its graph? See, now if I draw this graph over here, if I write here, this is time, and time is going to pass for 1 hour. Time will only go forward this way, okay? And the position graph, it could be distance. Sometimes they write distance, sometimes position, sometimes displacement. So here's distance. Can you draw this graph? So the tortoise is always at position 3. So it will always be at this point, right? Let me change the color. The tortoise will always be at 3. This is 3. So it's 3. And time goes forward. So time will go like this. So the more time it stays there and not moves, the more forward it will go. It will be aligned at point 3. Okay, but sometimes they might ask you for a speed time graph. It will be different. So if I ask for speed time graph, okay, so what is the speed of the tortoise? It's not moving. Its speed is 0. Okay. So after 1 minute, still 0 because it's not moving. 2 minutes, it's still 0. So you would see time goes forward, but the tortoise will be at 0 here. So sometimes we confuse these two. Okay. So they are different. Okay. Now let's go and deal with the question. So I'm going to clean this part. Now with this explanation, let's read it. A tortoise challenges a hare to a race. The hare eagerly, agrees and quickly runs ahead, leaving the slow-moving tortoise behind. Confident that he will win, the hare stops to take a nap. Meanwhile, the tortoise walks slow, steady pace for entire race. So which one is the tortoise, right? The turtle, right? And this one, it's going with steady speed, which is going to be like this one. In all these cases, this is going to be the turtle, the tortoise, right? It's going to be this one. Okay. This one, however, D, you see, it's not. Like at this point, even the turtle is changing speed, which is not going to work, right? So this one also, but this one is also the tortoise, right? We have one that is like this. So only D is out with this sentence. Okay. D can't be the answer. Okay. The hare awakes and runs to finish line, only to find the tortoise already there. Which of the following graphs matches the description of the race, showing distance D traveled by the two animals over time? Okay, let's see now. So here, the hare went quickly, okay? Then that's exactly what I meant. See, when the hare starts to sleep, it's not moving, and then it gets fast again, right? So this one could be right. This one gets fast, sleeping, fast. This one is not. Look. Do you know what it means? This one, like, do you know what number 3 means? That means number 3 here, it means that the hare was going quickly to the right. And at this portion, because it's going back, like this is going down, that means it's going back to the left, right? That's more like physics, but it's not necessary. We just know that it's not the answer. That's all we need to know. This will be out as well. This one shows no sleeping because it's moving a little upward. So this is also out. So we have to choose between A and B. Now, okay, imagine, okay, this is the final place that they're going to go. This is the final distance. The winner reaches this in shorter amount of time, okay? So both of them will get to the end point. This is the end point. But which one has the earliest time, right? Look, this one will show the time. If you want to know, this will also show the time. If you go like this will show the time. This will show the time. Now remember, this one was the turtle, okay, or the tortoise. Now it gets to this position, this will be to T. The T for this one is longer. That means the tortoise got second. It took more time, okay? But look at this one, okay? This one will be the tortoise. So the T for the tortoise will be before than the hare. The hare will be here. This one was for the hare. So hare took longer to get there. So that means B is the right choice. Now, if you don't understand problem 5, I know why. Just listen to me. See, imagine we have a tortoise, okay? The tortoise is not moving. It's just sleeping at position 3, okay, at this position for 1 hour. Can you draw its graph? See, now if I draw this graph over here, if I write here, this is time, and time is going to pass for 1 hour. Time will only go forward this way, okay? And the position graph, it could be distance. Sometimes they write distance, sometimes position, sometimes displacement. So here's distance. Can you draw this graph? So the tortoise is always at position 3. So it will always be at this point, right? Let me change the color. The tortoise will always be at 3. This is 3. So it's 3. And time goes forward. So time will go like this. So the more time it stays there and not moves, the more forward it will go. It will be a line at point 3. Okay, but sometimes they might ask you for a speed time graph. It will be different. So if I ask for speed time graph, okay, so what is the speed of the tortoise? It's not moving. Its speed is 0, okay? So after 1 minute, still 0 because it's not moving. 2 minutes, still 0. So you would see time goes forward, but the tortoise will be at 0 here. So sometimes we confuse these two, okay? So they are different. Okay, now let's go and deal with the question. So I'm gonna clean this part. Now with this explanation, let's read it. A tortoise challenges a hare to a race. The hare eagerly, agrees and quickly runs ahead, leaving the slow-moving tortoise behind. Confident that he will win, the hare stops to take a nap. Meanwhile, the tortoise walks slow, steady pace for entire race. So, which one is the tortoise, right? The turtle, right? And this one, it's going with steady speed, which is going to be like this one. In all these cases, this is going to be the turtle, the tortoise, right? It's going to be this one. Okay. This one, however, D, you see, it's not. Like, at this point, even the turtle is changing speed, which is not going to work, right? So this one also, but this one is also the tortoise, right? We have one that is like this. So only D is out with this sentence, okay? D can't be the answer. Okay, the hare awakes and runs to finish line, only to find the tortoise already there. Which of the following graphs matches the description of the race, showing distance D traveled by the two animals over time? Okay, let's see now. So here, the hare went quickly, okay? Then that's exactly what I meant. See, when the hare starts to sleep, it's not moving, and then it gets fast again, right? So this one could be right. This one gets fast, sleeping fast. This one is not. Look. Do you know what it means? This one, like, do you know what number 3 means? That means number 3 here, it means that the hair was going quickly to the right. And at this portion, because it's going back, like this is going down, that means it's going back to the left, right? That's more like physics, but it's not necessary. We just know that it's not the answer. That's all we need to know. This will be out as well. This one shows no sleeping because it's moving a little upward. So this is also out. So we have to choose between A and B. Now, okay, imagine, okay, this is the final place that they're going to go. This is the final distance. The winner reaches this in shorter amount of time, okay? So both of them will get to the end point. This is the end point. But which one has the earliest time, right? Look, this one will show the time. If you want to know, this will also show the time. If you go like this will show the time. This will show the time. Now remember, this one was the turtle, okay, or the tortoise. Now it gets to this position. This will be to T. The T for this one is longer. That means the tortoise got second. It took more time, okay? But look at this one, okay? This one will be the tortoise. So the T for the tortoise will be before than the hare. The hare will be here. This one was for the hare. So hare took longer to get there. So that means B is the right choice. Now, before we do problem 6, let's understand more about line of symmetry. Okay, this word over here. A line of symmetry, okay, will divide the shape into 2 equal parts. Now, for this one, if I go from here, okay, so this part over here, the left side of it is equal to this side. Okay. Now, if I make this shape a little different and I add something like this to it, okay, so then the line of symmetry would be like this, okay? That's it. Now, the question is giving us a normal square, okay? Let's go with this one. Now, what are the lines of symmetry for this square? Okay, this would be 1. It turns it into 2 rectangles. This could be another one, 2 so far. I could also go like this, turning them into 2 triangles, and also like this. So we're going to have 4 lines of symmetry. Now, with this, let's go and actually do the question. There are 89 grid points. So you tell me how many points are here? It has to be 9 times 9, 81, right? Okay. In the square shown in the diagram below, including the points on the edges. Okay. Point P is the center of the square, given that Q is randomly chosen among the other 80 points. Okay. So this is P. Now let's pick, right? If I choose this one, for example, randomly, you tell me, is this a line of symmetry? Well, it's not, right? See, these 2 shapes might look a little similar with rotation, but the right side and the left side, they don't match. So for example, like we have this shape over here, right? Let's just see it here. if I just pick this, we need to have its equivalent right over here, but we don't have this. So that's not a line of symmetry, okay? So if it is a line of symmetry, for any given point, right, there has to be, if I go 90 degrees to this, and I continue the same, there has to be this point over here. There is no point like this, okay? So that's not a line of symmetry. Let's go and pick another one. This is P, and I'm gonna choose this. So if I just do that, you'll see that it's again the same story. Is this a line of symmetry? No. Is the left side the same as the right side? The answer is no. But what if I choose, for example, this one? Okay, then this will P and the Q. You would see that now it is a line of symmetry. Okay, so now what points are like this? These four, if I select any of these four, okay, we'll divide it like this, or any of this four. For any of these, I'll just draw like a vertical line like this. So, and also these four, right? So for these four, I could draw this one, right? Okay, into T. So this is gonna be the horizontal one. But remember when we started earlier, so these points, if Q is any of these points, any of them, then you can connect these two, then you get this line, which this is again another line of symmetry. So we just have to go these four, these four, these four, and these four. Okay. So what does the question want? I don't know if you finished it. What is the probability that the line PQ is a line of symmetry for that square? So if Q is one of these points, it will be a line of a square. If it's not one of these points, it's not a line of symmetry. So now here it says, am I gonna write it? First, let's count. Each of these shapes is 4, and we have 8 of them. 1, 2, 3, 4, 5, 8. So we have 32 points. So I'm going to write 32. Is it going to be 32 over 80 or 81? So here it says point P is in the center. Okay, given that the point Q is randomly chosen among the other 80 points, right? So Q, we just selected this 32 from these 80, okay? Now we just have to simplify this, okay? You could simplify it by 2, by 4, by 8, or the best one, 16, because both of them are divisible by 16. This divided by 16, this also divided by 16. We simplify it. This will be 2, this will be 5. So 2 over 5 will be the right choice for problem 6. Before we do problem 7, let me ask a simple question. What is the average of 10 and 10? So how do we do averages? We add them together, 10 plus 10. Okay, it's going to be 20. And we divide it by 2. Obviously, the answer is 10. Okay. So this is the average of the two numbers. Okay. We want to keep this average. Okay. So if I make this one 9, what happens? Okay, if the average still wants to be 10, that means this number wants to be 20. If this becomes 9, then this one has to be 11. Okay, let's do it one more time. If I make one of the numbers 2 less, 8. The other number has to be 2 more, 12. Okay, we want to keep the average at 10, for example. Now, if this becomes 5 less, this one has to be 5 more. Okay, so this idea is what makes problem 7, right? So I wouldn't call it difficult because it's not really. So let's just read it. Shwana takes 5 tests, each worth a maximum of 100 points. Her scores on the first 3 tests are like that. In order to average 81 for all tests, what is the lowest score she could earn on one of the other 2 tests? Let's see here. So when we want to find the average of 5 numbers, what do? We add all the numbers. So it's going to be 70. Let me make it orange again. It's going to be 76 plus 94 plus 87. Okay, and we have 2 more tests that we don't know. So I'm going to put test 1 plus test 2. We add these 2. We're supposed to divide them by 5, and the average will be 81, right? Okay. So how do you simplify this? Okay. One way would be to cross multiply. That means you would take these numbers multiplied by 1, which is any number multiplied by 1 is itself. So that would be the left side. Okay, so I'm going to write it here. This number 76 plus 94 plus 87 plus T1 and plus T2. Okay, that would be the left side. And the right side will be these 2. Okay, so 81 times 5. So I'm sorry, I have to write it like this. Okay, so there you go, we have this. Now let's go and simplify a little. Let me make this black. Okay, good. So let's add these numbers now. This is 170, right? Plus 87, 257. Okay, so 257, okay, plus these 2 values, plus T1 and T2 is equal to 81 times 5, which is going to be 405. So from here, we have T1 plus T2. We just have to subtract. So T1 plus T2 is equal to 405 minus 257. Okay, it's going to be 100, okay, 43 plus 5, 148, is it? Let's check. So it's going to 390. Yes, that's very good. So it is great. T1 plus T2 is 148. Now look at the answer. Do you remember the first example I gave at the beginning? Okay. If we want one of them to be maximum, then the other has to be minimum. Okay. So if we want to find the minimum, that means the other one has to go really, really high. So what is the maximum point of any of these 2 tests? It's 100. If one of them is 100, then the other one has to be as small as possible. So which will be 48. This is exactly what I gave the 10 plus 10 example. Okay. If you want to make the other one as little as possible, you have to take this as many as possible. So here the maximum is 100. It's a test. Then the other one will be simply a 48. So this 48 will be the answer to problem 7. Okay, for problem 8, I'm going to show you how you can do this under 30 seconds. Well, all you have to do is multiply 4 over 5 and multiply that by 9 over 10 and multiply this by 3 over 4, okay? And look, this 4 is canceled with this 4. So it's equal to 27 over 50, okay? I multiply both of them by 2. It's going to be 54 over 100. Okay, they are equal. And this is 54%. Okay. So you could do this even like in 15 seconds, 20 seconds. Okay. But how and why we could write this question like this. Let me explain now. Okay. Let me do some cleaning here. Okay. Okay, now imagine you want to buy a shirt. The shirt is actually $50, okay? And they want to give you a discount of 10%, okay? So how do you actually calculate this? Tell me. Most of my students, before I teach them, they will go, okay, what is 10% of 50? They will go write 50 here. Then they say 10% of that. They write it this way. Okay. If they're good at it, then they will write, okay, that's going to be like $5. So 10% of that is $5. So they go $50 minus $5. That's going to be $45. Is that correct? Yes. Is that a good idea? No. Okay. It's really bad because it's so slow. Okay. We don't want to do this like the questions like this. See, listen to me. If you have something, all of something is 100%, okay? If you want to take 10% of that, that means from this 100, we're going to take 10 of it. So what is this when we simplify it? It's going to be 90 over 100. You simplify it more, this is going to be 9 over 10, okay? Do you remember the shirt was 45 after the discount? So all I have to do is take this number and multiply it by this. Okay, so now take a look. 50 multiplied by 9 over 10 is actually $45. It's so much faster, right? So 90, when you want to say 10% discount, what does that mean? 10% discount means multiply the number by 9 over 10. What is 20% discount? Okay, if you want to give somebody 20% discount, let me write it. What is that? It's going to be multiplying something by, you remove 20% over 100. So that's going to be 80 over 100. So when you want to take 20% of something, multiply it by 80 over 100. You simplify this. This is actually 4 over 5. Okay. What is 50% discount? You multiply it by 1 over 2, a half. Okay. Now let's go and actually read the question and do it. And let's just learn more about this. Gilda has a bag of marbles. She gives 20% of them to her friend Pedro. Okay, from 100, we take 20. That's going to be 4 over 5. Why? I'll explain one more time. There is 100. You remove 20 from it, from the 100%. Okay, that's going to be 8 over 10. It's going to be 80 over 100. You divide both of these by 20. Then you get 4 over 5. Okay. So this is 4 over 5 to our friend Pedro. So then Gilda gives 10% of what is left to another friend. When you just give 10%, when you remove 10% from 100%, that's 9 over 10. Okay. And finally, Gilda gives 25% of what is now left in the bag to her brother Jimmy. So what is 25%? It's going to be 3 over 4. Is that clear? So let's just do it one more time. So you have 100 of something. When you remove 25 of it, so that's going to be 75 over 100. You just have to simplify it. Okay, both of these numbers are divisible by 25. I divide this by 25. I divide this by 25. 75 divided by 25 is 3. 100 divided by 25 is 4. So this is 3 over 4. Okay. Now let's go. So all you have to do is just multiply these numbers together. Okay, when we multiply, remember, all the numerators are multiplied together. 4 times 9 times 3. All the denominators are being multiplied together. Okay, so that means this number will cancel this number. Okay, so there is no other thing that could be simplified. So now let's go and multiply these two. 9 times 3, 27. 5 times 10, 50. It's 27 over 50. But percent means in hundreds. How can you take 50 to 100? We just multiply this by 2. So I just have to multiply this by 2. 27 times 2, 54. So 54 over 100 is 54%. There you go. Actually, percent sign should be here. So it's 54%. Let me write it correctly. Okay. So, which gives the option like E is the right choice. For problem 9, listen to me well, because I'm going to tell you a point that is actually more important than the problem itself. And probably you don't know it. So, and the point is, in this question, if I make all the 6s, I remove every word that has 6. If I replace all the 6 by 1, and if I replace all the 12s by 2, because 12 is 2 times of 6. If you do it with these values instead, do you think the answer to the question will change or not? Okay, remember, it's a ratio question. Okay, so this point is very, very important and could make a lot of questions a lot simpler. Okay. Now, let's read the question first. Alex and Felicia each have cats as pets. Alex buys food in cylindrical cans that are 6 centimeters in diameter and 12 centimeters high. Okay, so this would be for Alex. Okay. So, by the way, because the question is asking for the volume, okay, let's just review the formula for it. When we want to find the volume of a shape, right? So first, we would find the area over here, okay, of this part, whatever the shape is. And then we multiply it by the h, okay? Now, since this is a circle, and the formula for a circle is pi multiplied by radius of the circle, again multiplied by its radius, okay? So it's going to be pi r squared, and then we multiply that value by h, okay? So the formula we're going to follow is pi times r times another r squared, multiplied by h. We're going to follow this formula, okay? Alicia buys cat food in cylindrical cans that are 12 centimeters in diameter and 6 centimeters high. So this will be for Felicia. Okay, that's enough. Okay, what is the ratio of the volume, okay, of the Alex to the volume of Felicia? Okay, so the point that I want to give here, see, is it important? Like this one is 12. The height here is 12. This one is 6. And I want to replace them by 1 and 2. I just want to keep the ratio, okay? But I want to change the numbers. And the answer will not change. I'm going to make this 1. And I'm going to make this 2. Okay, I do this because it's a ratio question. Okay, so, and then for this one was 6. Actually, the diameter was 6. It doesn't matter. From here to here was 6. From here to here was 12. Okay, that means the radius of this is 2 times of this. So again, I'm going to make the question even simpler for myself. So I'm just going to call the smaller one 1. And I know this is twice of that. So the radius here is 2. And I'm going to do this instead. And it's not only for this question. You could do it for all questions that are asking for a fraction, that are asking for a ratio. It makes it so much easier. Now let's follow the formula. So for Alex, it's going to be pi r squared. Pi times, what is 1 squared? 1 times 1 is 1. Multiplied by the height, multiplied by 2. So what's that going to be? All of this is actually going to be 2 times pi. So I'm going to write this one as 2 pi. Okay, so for this one again, let's do this one. Pi times, this time r is 2. And r squared is 4 and multiplied by height, which is not going to change anything. Okay, so this one is actually 4 pi. Good. This is 4 pi. And what is the ratio of Alex to Felicia? 2 pi over 4 pi. Okay, so it's going to be like this, 2 pi and 4 pi. Both of them can be simplified, right? Or both of them can be simplified by 2 pi. So the ratio becomes 1 to 2. So the answer to the question is actually B. But learning to replace the values in questions that involve like ratio will just make you so much faster. Okay, before we actually do problem 10, let me just give you something crucial about averages. So answer me this. What is the average of 1, 2, 3, and 4? Okay, some of you will just add all these numbers together. 1 plus 2 plus 3 plus 4. That's going to be 10. And then you divide it by 4 because we have 4 numbers. That's going to be 2.5. Okay, the smarter people would say the average of the number is actually the average of these two. What is the average of 2 and 3? 2.5 again. Okay, so that's not the point we're going to focus on. What we're going to focus on here is this. If I remove this number 4 and write instead of it 8, what happens to the average? Remember, the average was 2.5. Now that I remove this 8, 4, and just remove it by 8, the average will become 3.5. And you don't even have to calculate it. How do I know? Okay, if I make this one, now the average is 2.5, right? So if I add this number, if I make this number 16, so then the average will be 5.5. And I don't even calculate it. How do I know? See, it's simple, right? When I make this number 8, okay, instead of 4, I'm adding a plus 4 to the number. It was 4, now it's 8, we added 4. But when we do the average, okay, we go like the sum of the numbers divided by 4. So when you add these 4 to it, okay, you're actually increasing the average by 4 over 4, which is 1. That's how I know that the average here will be added 1 to it would be 3.5. Okay, if it wasn't clear, just stay with me. We do more examples. Okay. Now, what is the average of these numbers? 2.5. I'm going to change, I'm going to add 8 to any of the numbers. So I'm going to make this one 10. What is the average of 1, 10, 3, and 4? Okay, without calculating it. I added 8. It was 2 is 10. I added 8. So the average would increase by 8. We have 4 numbers. You divide it by 4. The average increases by 2. It was 2.5. Now it will be 4.5. Okay, one more time. Okay, so now the average is 2.5. And we add the sum. It doesn't matter in any order. If we add 10 to these numbers. So if I make this one, any of them, 14. Now what is the average? I added 10 to all of these numbers. Their sum, I added 10. Okay. How much the average will increase? 10 divided by 4 because we have 4 numbers, 2.5. So I just go and add 2.5 to this. So the average of these numbers, 1, 2, 3, and 14, is actually 2.5 plus 2.5, 5. Okay, you just need this to become faster, okay? So even if you don't understand it, it's okay. But if you learn it, you're just so much faster and you can do things more quickly. Okay, so now let's clean these parts. And let's actually do the question. Okay, so now let's go. The diagram shows the number of students at soccer practice each weekday during last week. After computing the mean and the median values, coach discovers that there were actually 21 participants on Wednesday. So it's going to be like this. We have 16. It's the same question. We had 16. And we're going to remove it and write 21 instead of it. What we just practiced together right now. Okay. Which of the following statements describe the change in the mean and the median after the correction is made? So don't answer the question like this. It's confusing. Okay. Write it in like set of values that is familiar to us. So we know, okay, Monday is 20. I'm just going to write the 20 here. Tuesday is 26. I'm going to write 26 here. Wednesday is 16. Okay, I'm going to write the 16 here. Okay, so Thursday will be a 22. Well, this is 22. So I'm going to go put a 22 here. And Friday is 16. So, okay, don't calculate the average, right? The mean, don't calculate it. We don't need it. Now just tell me, what is the median? The median is 20. What is the average? Don't calculate it. Okay, here it says, okay, one of the 16s is going to be crossed. And instead of it, we're going to write 21. So the numbers look like this instead. It becomes 16. Then the second number will be 20. 20. And 21 becomes the third number. It will go right here. 20, 21, and the rest of the number, 22 and 26. Now, what is the median? 21. What was the median? 20. How much did it increase? 1. So the median increased by 1. But now what is the average? You remember what I told you. See, 16 became 21. It increased by 5, okay? So the sum increased by 5. Now, how much did the average increase? 21 minus 16 is 5, yeah? And this 5 was for 5 numbers, not for one number, okay? When you go 5, when all of them increased, okay? The average. So the sum increased, this 5, is going to be divided by all the 5 numbers. So actually the average only increased 1. So it's going to be like this. The median increased by 1 and the average or the mean also increased by 1. And we don't need to calculate the mean, right? One of them increased by 5. We have 5 numbers. 5 divided by 5 is 1. That's it. So the mean increased by 1, the median increased by 1. B is the answer. For problem 11, you just have to visualize the question. Even if you don't want to just write it down, you just have to visualize it, okay, in your mind quickly, and then give the answer to the question. So the 8th grade class at Lincoln Middle School has 93 students. Okay. Each student takes a math class or a foreign language class or both. There are 70 8th graders taking a math class. So 70 people are the people who take the math class. And there are 54 8th graders taking a foreign language class. Okay, so 54 people here. Now, if we add, it makes sense to add all these people together, right? So what is 70 plus 54? Okay. 70 plus 54. Okay. That would be 124 students. Okay. That would become 124. But here it says there are only 93 students. But here, when we add these numbers, it makes 124 students. What just happened? Okay. The problem is there's some people who take both, okay? And we're counting these people twice. They appear in math class and they appear in language class. So that means we're counting these people who are in the middle 2 times. So how to find these people who are like taking part in both classes? We just have to minus this. 124, which we have, minus all the students that we have, which is 93, is going to be 31. Okay, so these 31 people, okay, are exactly right in the middle over here. So let me just clear this up a little. So 31 people are actually here in the middle. I'm going to go with orange here. Okay, so, but how many people take math? 70 people. Okay, so that means 39 people just take math alone. Okay, and what is 54 minus 31? That's going to be 23. So 23 people only take math, 23 people take language class, 39 people take math class, and 31 are in the middle. Okay, so what is the question 1? How many 8th graders take only a math class and not a foreign class? It would be just like these 39 people. So we just have to choose option D. So if it's visualization of these cubes and how they turn is difficult for you, there are things we could do to make it easier. So let's read the question first. The faces of a cube are painted in 6 different colors. These views of the cubes are shown below. What is the color of the face opposite of the aqua face? Okay, now by comparison, okay, of these B's together, so if I want to turn this B into this B, how should I rotate this? I should go on this page, like focus on this page, and I should rotate it on the same page 90 degrees. I have something here. If this is B, okay, we just have to go 90 degrees just like that. Then this B becomes this B. Okay, so that's why if we turn this 90 degrees, this R will go all the way and becomes this R, obviously. So what is so cool about this? Now, if we just turn this W, if this is the W, so, and then we turn it, the W goes just right behind this. So that means W will be right over here. Okay, so this red one right over here is actually our W. So what is so important? Now we know that G and W are in front of one another. Okay, so opposite of W is G. So I'm going to write it this way. Okay, and there is nothing else to learn from this. So now let's compare this one and this one. How can we make this G into this G? Okay, again, on the same page, I have to turn this 90 degrees this way. So if it's this one, okay, if it's this one, I don't know if you see it. I have to turn it. It's hard. It's different in the camera. So I think it's just better to just go like this. So this one, we'll turn it into this one right over here. Okay. So that's why if we do it like this, look what happens to the R. This R, okay, will go and become this R because we're going this way. Okay. So what happens to the P? If R goes down and R becomes this, then what happens to the P? So P would also go to the bottom here. So what does that mean? That means P is right over here. This is also P. Okay. So if this is P and this is B, so B and P are in front and opposite of one another. So B and P are like this. So two colors are left. So the two colors that are left are supposed to be in front of one another. So what colors are left? Aqua is left and R is also left. So then they have to be opposite. So what is opposite? What is the color of the face opposite to aqua face? It has to be red. If you can't do problem 13, the only reason is that you really do not understand this problem. If you really understand it, it's easy. Not just this problem 13. Usually all AMC8 questions after question 10, 11, 12, 13, these questions, the main challenge is understanding them. So a palindrome is a number that has the same value when read from left to right or from right to left. So for example, this number 1, 2, 3, 2, 1. If I read it from the right, 1, 2, 3, 2, 1. Okay. So for example, 2, 3, 1, is it a palindrome? No. Okay. Now, let's n be the least three-digit integer, which is not a palindrome, but which is the sum of three distinct two-digit palindrome. What is the sum of the digits of n? See, you think everybody that reads it understands it? I promise you, everybody doesn't understand it fully, like what they're going to do, right? But who can actually understand it? The person who goes back to the beginning and make this smaller. So let n be the least three-digit integer. So it has to be an integer, a whole number. It has to be a three-digit number. And it has to be the least. What is the least three-digit number? 100. So first you understand this, which is not a palindrome. Is this a palindrome? No. So good, right? We're closer. Okay, maybe 100 is even the answer. Okay, which is the sum of three distinct two-digit palindromes. So again, if you want to understand this, we go from right to left. So can you give me some two-digit palindromes? 11 is 1, 22 is 1, 33 is 1. And what is the last one? The last one is 99. So why does it say distinct? Because they're going to be different. So for example, I can't write 44 plus 44 plus 44. Why not? They're not distinct. So we understand so far three distinct, and the sum mean we have to add them. When we add these numbers, they're supposed to be the smallest three-digit number. Okay, let's go and see. Now, most of the time, we're still not sure what the question means 100%. So we just go with something like this. I want the smallest, right? I go with this. So if I add them all, 66. Is this the answer? No. Why not? It's now three-digit. So I need to add more. So you just play with the question. Hopefully you get to this. Now, what do I get from here? If I have like this, it's going to be 99. Is it three-digit? No. Now look, it doesn't matter which one I change or how I write it. If I add one more, like for example, if I want to increase it one step more, I have to make this one 55. So that means I have to add 11 to it. And there's no other way. There can't be something smaller than this, right? So that means the number will be something like this, right? There are different ways of writing it. So for example, if I want to get 99, it's not only this way, there are more ways to get that. I could go with 11. I could go, let me make it purple. 11, 33, and 55. This is again 99. So you see, maybe I add 11 to this becomes 22. Or if this one becomes 45, again, I have to add 11. Even if I want to make this 66, again, I have to add 11. So there's no way. It doesn't matter how you write it. The next one, if I make this 22, this one will also be added 11 to it. So now 22 plus 33 plus 55 is equal to 110. So what is the sum of these digits? 1 plus 1, which is going to be 2. So can I answer it faster? Yes. See, now when you just read the question, that is going to be 3 numbers like this, we know that all these numbers are multiple of 11. So that means the sum of these 3 numbers, when you add them all up, the result is also multiple of 11. So you just have to find a number that is a multiple of 11 and it's also a 3-digit. So, which is going to be 110 again. So this is the smallest 3-digit number that is also a multiple of 11. So 1 plus 1, 2, A is the right choice. Problem 14, with the right approach, it's extremely easy and simple. Let's go and read it. Problem 14, Isabella has 6 coupons that can be redeemed for free ice cream cones at Pete's Sweet Treats. In order to make the coupons last, she decides that she will redeem one every 10 days until she has used them all. She knows that Pete's is closed on Sundays, but she circles the 6 days on her calendar. She realizes that no circled date falls on a Sunday. On what day of the week does Isabella redeem her first coupon? So how do you do this? Are you gonna just go, for example, choose Tuesday? Let's start with Tuesday, and then add 10 days to it, like Wednesday, and then you see what day it is, and then you repeat the same process. No, we're not gonna do this. Okay, that's gonna take a lot of time, and we're gonna make a mistake. So the first thing that we need to know is that 10 days later is equal to how many days later? See, how many days is a week? And it repeats itself after 7 days. So 10 days later is equal to 3 days later. Okay, so we're not going to add 10 days to them. We're just going to add 3 days. Okay, and you see that how we have Monday, Tuesday, Wednesday. So we already have something like a map, a diagram. So we just have to add Saturday and then Sunday here. And now, so again, what most people do, they choose, for example, Monday, and then they go, what is 3 days after that? Is that the best idea? Still no. Okay, so we're gonna go 3 days backward. So if it's Sunday, 1 back, 2 back, Thursday. So Thursday is out. Why? If I buy 1 ice cream on Thursday, that's good. 10 days later, which is equal to 3 days later, Sunday. So because it becomes Sunday, Thursday is out. Okay, now let's go back 3 days. 1 day, 2 day, 3 days. So Monday is out. Why? If I buy one ice cream on Monday, fine. 10 days later will become Thursday, fine. 10 days later it will become Sunday, not fine. So we just have to go back 3 days and cross. So this is Monday. 1 day before Monday is 1, 2, 3. Friday is out. Bye-bye Friday. So 3 days again. 1, 2, 3. Tuesday is out. What remains? It's just Wednesday. Easy. If you can't do problem 15, there is only one reason. And the reason is that you don't understand the question 100%. If you understand it, then you will do it. On a beach, 50 people are wearing sunglasses and 35 people are wearing caps. I made the orange one 35. It's just a little smaller. So wearing caps, 35. So the larger one is actually wearing sunglasses and it's actually 50. Okay. Now, some people are wearing both sunglasses and caps. When you just read this sentence in any test, immediately you have to think of this diagram. Okay. Or even if you don't want to draw it, you have to think about it and imagine it the same way. Now, the most important sentence, if one of the people wearing a cap is selected at random. So that means we're focusing on the orange circle. If we choose a person from these 35 people, okay, the probability that the person is also wearing a sunglasses, that means this part. The probability of being this part is 2/5. What does that mean? The orange, if we say the orange is all of something, then this middle part is 2/5 of all. Okay, now we know that all of this is actually 35. Okay, let me clear this. So that means this part is 2/5 of 35. This is how we write it. And we just have to simplify it. Okay, some students have problems with this. When I do it like that, it gets easier for them. So now you could see this one is simplified by that is 7. 7 times 2 is 14. So I'm going to go here. So that middle part is actually 14. Good. So now help me. What is this part? The part that is in the orange part, caps part, but does not belong in the 14 part. So 35 minus 14 is 21. So this part is 21. Let's do this with the other part. Okay, we had a total of 50. 14 is common, so that's going to be 36. Okay, there you go. So we have a complete diagram and we have a full understanding of the situation. So what is the question? Bring it on. If instead someone wearing sunglasses is selected, so we just want probability, right? We want probability. So all of this, we're focusing on this. All of it is 50. Okay. What is the probability that this person is also wearing a cap? Again, it's talking about this part. So what is the probability that you choose this? So 14 in the middle divided by all of it. So we just have to simplify it. Both of them are even numbers, so we can divide them by 2. Let's divide them by 2. 14 divided by 2 is 7. 50 divided by 2 is 25. Okay, which results in option B. Okay, I'm pretty sure a lot of students are challenged with this type of questions. Okay, the first thing that students make a mistake is this. So imagine I go with the speed of, for example, 10 meters per second, and then I go with the speed of 50 meters per second. What is my average speed? Can I go like, okay, I go 10 plus 50 divided by 2 is 30 Can I do that? Is that how we find average speed? The answer is no, it's completely wrong. But why is that wrong? Because you don't know how long I went with this. Maybe I went like 2 seconds with this speed, and then I went like 5 hours with this speed. So most of the time I went with 50. So my average should be very close to 50. Okay. So because you don't have how long I went with this, and you don't know how long I went with this, so you can't find the average like that. So how do we find the average speed? The average speed is the total distance. That means all the distance we go. Maybe if there's more d1 plus d2, how much of a distance I go divided by all the time. Maybe first for d1 sometime, maybe I wait somewhere. All the time will be added here. t1, t2, whatever it is. Okay. So total distance divided by total time will give us average speed. Okay. So now that we know average speed, let's start problem 16. Wang drives 15 miles at an average speed of 30 miles per hour. Okay. So my recommendation is when you do this question, imagine you are the person and see it as a story. Okay. You're starting from your home. Imagine this. And you go, okay, say we go 15 miles forward and we go with this speed. And how long does it take? In 1 hour, we go 30. We want to go 15. So half an hour is enough. So we go 15 miles in 1/2. Let me change the color. It doesn't look good. So in half an hour. Okay, so we are at this position. Okay, is that the end? No. We're going to go more. So how many additional miles will we have to drive at the speed of 55 per hour? So we're going to continue going like this. And look at the options. They're all more than 15, right? This is short. So I'm going to go more distance, right? I'm going to go a long, long, long way. Okay. So do we know how long the trip is? No, we don't know. So it's the distance. Okay. And so we want to find the distance. Well, we have to drive at 55 miles per hour. So we have our speed. We're going to go with 55 miles per hour. So that the average speed is 50. Okay. So remember, total distance over total time is supposed to be 50. So let me write it here. So the answer, whatever we do, this is supposed to be 50 miles per hour, the average one. So as I told you before, we have to add all the distances and write it here. First 15. Okay, then we have to go with the distance of d. Okay, so now what is the time? At first, it took us half an hour. You could write it as 0.5, or you could write it as a fraction, whichever you're more comfortable with. And then we need the time. Do we have the time? No. So what should we do? So I think the best way to do like the questions like this is usually go through the options and do trial and error rather than solving an equation. It's much, much faster. So which one do you want to try first? We know that the speed is 50 miles per hour. In 1 hour, we go 55. So which one is easier to pick, right? I would pick 101 to try. Okay, this is not the answer. I just want to try it. Why? Because it's exactly 2 times of this. Okay, so I go 55 miles in 1 hour. I go 2 times of that in 2 hours. Okay. So then I know the time. So I'll just gonna try. If this is 110 and my speed is 55, I just have to go 2 hours with this speed to get 101. So I just write 2. And now I'll just try. If I simplify and this becomes 50, then my guess D would be right. If it's not 50, my guess would be wrong. I have to pick another one. So let's go into it. 110 plus 15 is 125. I'm going to write it here. This is actually going to be 2.5. Okay, so simplify it any way you want. So to make it easy for everyone, I'm going to multiply both of these by 2. Why do I multiply it by 2? To get rid of this decimal. I don't like it. So what's that going to be? Multiplied by 2 is 250. And 2.5 times 2 is 5. 250 divided by 5 is 50. Here you go. So the question set is supposed to be 50, and I got 50. So that means our answer was correct. Okay. So usually the best way is go through options. Usually that's way faster. Okay. But maybe you want to learn the general way. Okay, let's complete this. So imagine you want to go the general way. So if this is the distance, okay, so now we just need to put time. And to get time, what did we do? How did we find 2 hours? How did we find 2 hours? We divided 110, which was the distance, by 55, which was the speed. That's how we got 2 hours. So that's going to be distance over time. Okay. So, and by the way, sorry, distance over speed. So speed is 55. So as you see now, we have one equation, right? And there's only one variable. We just have to find D. Okay. You could go on and simplify this. You're going to get that the D will end up being 110. I don't like this. It takes too much. Okay. Problem 17 is like a blowfish because it's actually looking bigger, more difficult than it actually is, right? It just looks scary, but it's very simple. Okay. So let's just see how simple it is. Okay. So let's just check. I'm just going to do the first 2 terms. You see that we have all these numbers. First of all, what's the meaning of a point? Yeah, I'm pretty sure that you know it's a cross. So it's just we're multiplying them over 2 and times 2. Okay, and what's the meaning of these brackets? Brackets means again multiply. So we are multiplying this, the first one, with the second. Okay, 2 times 4. 3 times 3. So, and then how do we deal with them, right? So we just know that all these numerators are being multiplied together and all the denominators also are in another group. So really, I could just go on and make a big fraction line. I'll write all of them. 1 times 3 times 2 times 4 and then 3 times. Sorry, let's start with 2. 2 times 2 times 3 times 3. And look, see, I could simplify these numbers now. I could, for example, go and simplify this 3 by this 3. Okay, where is it? It's going to be this 3 on the question with this 3. Okay. And I could also go this 2 by this 2. See, I'm canceling all of these things together. Okay, so you get the idea, right? And if you look more closely, you see there is a pattern. 1, 3, 2, 4. The difference is always 2. When there is a pattern, we have to find also a pattern in a way we start to simplify. So that's the only difficult part of the question, is finding a pattern. So by the way, see, I'm going to just write some more. What is the next bracket here? The next bracket, okay, 2, 2, 3, 3, 4, 4. So the next one is 5 times 5. And this one, 1, 3, 2, 4, 3, 5. Okay, this is 1, 2, 3. The next one is 4. And their difference is always 2. 3 is 2 more than this, 2 more than this, 2 more than this. So this will be the next one. And you could just start creating and go like this. Now, you just have to spot a pattern. See, now let's start from here. This 3 goes with this 3. This 3 cancels with all 3. So all the 3s are gone. See, all of them are canceled. Let's do this with 4. This 4 is canceled. Let me change the color. This 4 is canceled with this 4. And this 4 is canceled with this 4. You see that all the numbers in the middle are disappearing. Okay? So let's do this for 98 here. This 98 goes with this. This 98 goes with the number beforehand, like the other ones. For example, these two. So, and this 99, I want to change color again, will cancel by this 99. By these 199 at the end, there's no next number here to cancel them. So these two will be left. Let's go to the starting point. I could cancel one of the 2's with one of the 2's. So what will be left eventually? 1 over 2 times 100 over 99. And I want to cancel this 2 by this 100. So this will be 50. So the total number is 50 over 99. So I'm going to select B. Not very difficult, was it? Okay, problem 18. The faces of each of the 2 third dice are numbered this. When the 2 dice are tossed, what is the probability that their sum will be an even number? So I think it's clear that we have 6 options. You're going to roll 2 dice. So you're going to get 6 times 6 options, right? So one way to answer this question would be to make a list, but that's not the best way to do it, okay? The best way is like this. We want an even number, right? So imagine that you're gonna like roll a dice once and again roll another die. So just do them, imagine that they are not happening at the same time. This will be easier. So how can we get an even number when we are adding them? Because here it says there's sum. We know that, okay, even plus even, okay, will be even. We know odd plus odd will also be even, right? So that makes 2 cases, right? So let's do this individually. It would be so much easier. So you roll the first die. What is the chance that you get an even number? So 2 is even, 8 is even, right? From all the 6 numbers, 2 of them are even. What is the chance? 2 over 6. And you do this, you take another dice, you roll it again. What is the chance to get an even number? Like this. So simplify it, that would be 1 over 9. The chance of getting even, when the first one is even, this one is even. But we could also get odd and odd to create an even number. Let's do that. So case number 2 will be like this. Now, what is the chance that you get an odd number? You just roll the die. So 1 odd, 2 odd, 3, and 4. 4 of them are odd from the 6. And so imagine you get another odd. So what is the chance to get 1 odd? And you roll it. Again, another odd. So it will be 4 6 of 4 6. Yeah. So you simplify it. It's going to be 2/3 times 2/3. Remember, numerators are together, denominators are together. Once you simplify it, it's going to be 4 over 9. So there are two ways to get even number. So the total chance would be addition of these. So you just have to add them. 4 over 9 plus 1 over 9 is going to be 5 over 9. So I think this is the easiest and the best way to see the question. Problem 19. This problem is difficult for students who are very instruction based. What do I mean by that? I mean, like they want to say, I see a question, first I do this, then I do this, then I do this. They want to have everything figured out before they actually do the question, right? But if you think of all questions like that, well, these type of questions, they're going to be really difficult for you, right? But instead, when you read a question like this, you need to draw a diagram, something for you on a paper so that you understand the question more, and then you could actually deal with it. Let's do that together. In a tournament, there are 6 teams that play each other twice. A team earns 3 points for a win, 1 point for a draw, and 0 points for a loss, just like soccer game, right? Football. After all the games have been played, it turns out that the top 3 teams earned the same number of total points. Important. What is the greatest possible number of total points for each of the top 3 teams? Okay, so the top 3 teams, okay, they're going to have equal points. So how does that going to work if we have like 6 teams and we want the winners to score as high, as many as possible? That means we want 3 loser teams that lose all the games to these 3 top players. So that's why I'm going to write it like this. We're going to have like top teams. It's going to be like winner 1, winner teams number 2, winner teams number 3, and we're going to have some loser teams. Okay, these loser teams are going to lose as much as possible so that these collect as many as possible. So they're going to have 2, right? And we know these are supposed to be equal eventually, these 3. Good. So let's take this one, for example. It's going to play 2 games with this. It's going to win both games. 3 times 2, 6. So collect 6 from these 2 games. Select another 6. Select another 6. So each of these winner teams, when they play with these losers, they're gonna get 18 already. Okay, they already have collected 18. But then, okay, these winner teams have to play against one another, right? If, for example, this team like plays against all of them and wins all the games, so it's going to collect more than W2 and W3, but we want them to be equal. So even W1 has to lose, okay, and win some, because we want W1, W2, and W3 to all be equal. So to make it easier to understand, by the way, I want you to think of this even when you don't want to do it. When you imagine the question, you could imagine the question like this, something with this model. So like you imagine these teams, okay, W1, W2, W3. So each line means a game. So W1 and W2 play, these 2 play, these 2 play. That's going to be 1 game each. Now, 2 games with this, 2 games with this, 2 games with this. So if somebody asks you how many games W1 plays, the answer is 4. 2 with this, 2 with this. So what is the total number of games they play together? Like these teams among themselves, the winner. So this is the number of lines. So they play 6. So 6 games is all, and we want to share them equally among all the 3 teams. So that means of these 6 teams, each team has to win only 2. Okay, 2 wins for you, 2 wins for you, 2 wins for you. Okay, that's very good. So, and then they're gonna also lose 2 games. Okay, but each team gets 2. And each of these wins means 3 points. Okay, so that means each of these teams get a 6 from their win. You get 6, you get 6. So all of them get a +6 when they play among themselves. Okay, so the answer will be 18 plus 6, 24. One more point. Remember, each team was playing 4 games. If all the teams have draws among themselves, okay, they play 4 games, 4 draws, 4 points. But when they win and lose, they get 6 points and want to maximize it. So obviously 6 is better than 4. So 18 plus 6, 24. So I just don't see this problem 19 as a single question. You could apply it to many questions, right? The questions that when you read them at first, you have no clue, but you need to write some models, break the questions, break it down for you so that you understand it fully. Then you could answer it. Well, problem 20 is tricky. It's not difficult, but it's tricky. Like, it's easy to make a mistake. Usually, because this is squared, and we know 4 is also squared, what we usually do, the fastest way is you take a square roots of both sides, and then you continue. But I'm going to write it like this. Okay, so I'm going to expand the left side times x squared minus 5 is equal to 16, right? So remember, okay, 4 times 4 is 16, okay? We also know that -4 multiplied by -4, okay, this is also 16. That's why we're going to write this way. We're going to go, okay, x squared minus 5, okay, maybe it's 4, okay, maybe it's -4. So we're going to have 2 equations to deal with. So that's going to be -4. So we're no longer going to need any of this, okay? So both sides, +5 added to both sides. We're going to have x squared is equal to 4 plus 5 is 9. This one, again, add +5 to both sides. So then it's going to be +5 minus 4, 1. So now, again, with the same reasoning, right? So we're going to have 2 numbers. X times x is actually 9, right? So 3 times 3 is 9. -3 times -3 is also 9, right? So that's why the first equation will give us 2 solutions, positive, -3. With the same reasoning, -1 times -1 is 1. And of course, 1 times 1 is 1. So we're going to have, this one will give us 2 options, +1 and -1. So how many different real numbers x satisfy the equation? As you see, we're going to have 4 numbers as solutions. Problem 21 may need a little extra time compared to other questions, but if you know what to do, if you really understand the question, then it's going to be very straightforward. What is the area of the triangle formed by the lines? You see the lines here. I'm not going to read them. See, when we have lines, okay, they're going to have intersections, okay? And the lines, when they intersect, they're going to create eventually a triangle, right? If they have different slopes. So how to find this triangle? You just need to find the intersections, okay? So one way would be just quickly find the intersection of these 2 lines, okay? These 2, and lastly, these 2. It will give you exactly these 3 points. Then once you have the points, then you could draw them if it's unclear, and then you know what to do. But in this question, I want to make the question a little longer so that we learn more. I actually want to draw all the lines first. You don't have to do it in the test. I just want everybody to see the lines. Okay, extra practice. We're gonna learn more. So let's just start off by this line over here. It's going to be y equal 5. Okay, remember, this is the x-axis. This is the y-axis. Okay, so y is always 5, right? So that means if x is 1, y is 5. If x is 2, y is still 5. If x is 10, y is still 5. So y5 is here. If x1, it would be here. If x is 2, y is still 2 here. If x is 10, y is still 5. So you would see if I connect all these lines, I'm going to get, right, this line over here. This is y equal 5. For every value of x, whatever it is, straight line. Good. Now, remember, to draw a line, you just need 2 points. Okay, I'm going to go the easiest point for this one. If x is 0, what is y? Y will be 1 plus 0, which is going to be 1, right? Now, if x is 1, instead of x, put 1. 1 plus 1 is 2. Okay, just plug in the values. So let me draw these two. Okay, 0x, y 1. Okay, x is 1, y is 2. It's going to give me these two. And I'm going to just draw it. So remember, a line will continue infinitely. Like I could continue it as much as I want. And lastly, I'm going to just try to draw the last one. Okay, by the way, let me write it on top of it. 1 plus y, 1 plus x. Okay, and let me go blue. So for this one, if x is 0, y is 1. If x is 1, y is 0. So I'm going to get these 2 points here. So 0 and 1, 1 and 0. So I have to continue. Remember, it goes like this. If I continue it, see, there's no triangle because I didn't continue line 5 enough, so I have to increase it. Okay, so there you go. Now I have all the 3 lines, okay? Now this is what it looks like, okay? So from here, if you have drawn a very good sketch, so you could trust your drawing. If you could trust it, well, I can't trust my own drawing. I know that the height is 4. Okay, I know the height is 4, but we're not sure for the base, are we? I don't know if it's 3 or 4. So mine is not that precise. So again, we have to go and find the intersection points. Remember, this part was extra. You don't have to do this during the test. So now the red one was this, okay? And this was the orange one, y1 plus x. So let's find the intersection of these two. Okay, the yellow and the red, it would be right over here. Let's find our first point. Okay, so to do that, okay, we say this y, if they are cutting, if they make the same point, so the x value and the y value have to be the same. That's why they are intersecting. So this y should be the same as this y. That means 1 plus x should be equal to this one. So that will give us x is equal to 4. Okay, and y is 5. So I have it here. So this one is actually 4, you see? This one will go on the 4 part. My picture was not that precise. Okay, so we just have to find the intersection of the blue and the red. It's going to be like this one. So blue and the red, it would be this one and this one. So the y's have to be equal. So I'm going to go 5 is equal to 1 minus x. So you see that now from here, x would actually be negative 4. So there you go. I already have, so from here to here is again another 4. So to here is again 4. So the base of the triangle is 8, and we already have the height, which is 4. So the area will be 4. The height is 4. The base, the red one, 8, divided by 2 will be 16. So 16 is the answer, right? So, but how do we find the intersection of these 2 points right over here? In case you wonder, I'm going to highlight it, make it really, really big. So that means the blue one and the orange one, they have to intersect. Okay, let's see. That means this line and this line, they should have the same points. The y value of both of them should be the same. So the right side of this should be equal to the right side of this. 1 plus x is equal to 1 minus x. So it's going to have 2x, then we're going to have 2x is equal to 0. So you would see that x will be 0, and we already knew that x was 0. So instead of any of them, you put x 0. So for example, if x is 0, 1 plus 0, so y will be 1, which is going to be this point here. We already know it. Okay, so this is the picture if you want to visualize it. You're gonna have it, but you didn't have to do it. We just need the intersection points, and there you can just go quickly and answer the question. Not difficult. So this is again another easy problem if you just have the right approach. I want you to watch the problem 8 because I talked about percentages. Okay, in problem 8 I said when you, for example, want to show 20% increase, okay, when something is increasing by 20%, you have to multiply whatever the number is by 6.5, okay? And you need to turn like percentages into fractions. Then it would be very easy to deal with them, okay? So, for example, let me give you an example. So if we have, well, something is $100, if we increase it by 20%, right, it becomes 120. Okay, so most people first find 20% of 100, then add it. It's correct, but it's long. Okay, so what we do, this is 100%. Okay, when you add 20 to it, it's like you have to multiply it by this value, which is going to be 120 over 100. Okay, and then you simplify it. So both of them are simplified by 20, so you get 6 over 5. Okay, that's it. So we'll watch problem 8 before you do this one. Now here it says, let's read the question. The store increased the original price of a shirt by a certain percent and then decreased the new price by the same amount. So, for example, you could increase it by 30%, and then you could decrease it by 30%. Is it going to be the original price? No. Good. Given that the resulting price was 84% of the original price, by what percent was the price increased and decreased? Okay, so let's go like this. So I don't have to write the equations because I already have the options. So I'm going to go with the easiest option, which is 20, and I'm going to try. So when you increase something by 20%, I just said it's equal to 6.5. And when you decrease it by 20%, this is 100%, you minus it 20, it's going to be 80 over 100. So if you multiply this, if you simplify both numerator and denominator by 20, you're going to get 4 over 5. So let me write it. here. This is 4/5. So numerators together, denominators together, 24/25. But I want this in percentages. So I should multiply both sides by. I want the denominator to be 100. So I have to multiply everything by 4. Okay, so by 4 here, by 4 here. So I'm going to get 96/100. So what does that mean? When you increase something by 20% and then you decrease it by 20%, you're going to get a 4% reduction. But we want this number to be 16 reduction. So that means 20 is not even close, right? So this option is out. This is definitely out because we want a bigger discount, decrease and increase. So the easiest one to try will be 40. I'm going to go and try 40 now. See, I'm going to write it the long version so that everybody understands, but you don't have to write it this way. You could simplify it before even you write it. This is 40% increase. What is 40% decrease? 100 minus 40 over 100, which is 60/100. You don't have to write it the way I do. I'm just writing it so that it's clear for everyone, right? Now we just have to simplify. Look, this 0, change color. This with this, this with this. Okay, so it's going to be 40 times 6/100. So what is 40 times 6? 60 plus 24? 84%. There you go. So the answer is E, because we tried 40%. See, this is like the easiest way you could do this. You could just do the same thing, right? If you don't like this way, which I recommend you do it like this, you could say, so 100 minus what? We decrease it by something. We also increase it by something. And when we do so, it's going to be 84% of the original one. You could try this equation instead, especially when you don't have the options. Imagine it's a test, you don't have the options. You should solve this equation. If you do, x will be 40 again. So up to you. I don't recommend this. Usually it's faster to try out the options. If you think this question is difficult or you're not doing it right, if you do it the right way, it's one of the easiest questions ever. Okay, so let's read the question and I tell you how you could do this one very easily. Well, after E high school's last basketball game, it was determined that 1/4 of the team's points were scored by Alexa. Okay, so what do we know? Whatever the number is, we can divide it by 4, right? Can the total score of the team be 21? No, because we can't divide it by 4. So we know whatever the number of points is, we could divide it by 4. Okay, and 2 sevens were scored by Brittany. Okay, so this number should also be divisible by 7, right? So the number of the points is something that you can divide by 7 and divide by 4, like 28. Can it be 27? No, because 27 is not divisible by 4, it's not divisible by 7. So, okay, and let's read the rest of the question. And then Chelsea scored 15 points, and none of the other 7 team members scored more than 2 points, right? What does that mean? That means the rest of the team members, they didn't play so well, right? The 7 players, okay, they scored fewer than 2 or equal to 2. So that means whatever the number is going to be smaller than 14, okay? So now it's easy, okay? So why do we have to write equations when we already know the number is divisible both by 4 and 7? So what is the least common multiple of 7 and 4? 7 times 4, 28. Let's try. Maybe 28 is the right answer. So 1/4 of the team points by Alexa, 28 divided by 4 is 7. So Alexa scored 7. Brittany scored 2 sevens. So this divided by 7, then multiplied by 2 is 8. So Brittany scored 8. Good. Let me write it better. Good. And then Chelsea scored 15 points. So 7 for Alexa, 8 for Brittany, 15 for Chelsea. That gets you a total of 30 already. But here we had the assumption that was 28. It's already more than 30. So it's contradiction. So that means 28 is not the right answer. So what should we do? Okay, we just try the next number, the next multiple of 7 and 4. So let's just write it here. So remember, we want a number that is divisible by 7 by 4. And the next number would be 6 times 4 times 2. So let me write it here. It's 56, isn't it? So if this is 56, 1/4 of the team's scores were scored by Alexa. Okay, so that would be 14 by Alexa. 2 sevens of this, okay. So that would be 8 by Brittany. This would be 16. Remember, you just have to divide this number by 7, okay, which you get 4 times 2, 8, and then you multiply it by 2 is going to be 16 that I wrote here. Nothing complicated. Okay, and then 15 is scored by Chelsea. So let's add them up. Alexa 14, Brittany 16, that's 30 already, plus 15 is 45. So what was the total score? Our assumption was 56. So how many more scores? 56 minus 45, that's going to be 11. Okay, so, and now here we had another condition. None of the other team members scored more than 2 points. We said that means it has to be smaller than 14, which is smaller than 14. So we found our right answer. 11 is as simple as that, right? Why do you want to write equations when you could do it like this? And I had to explain it to you. If I wanted to do it myself, under a minute. Now, before I actually do problem 24 and give the solution, we're going to use this opportunity to learn not only this question, but a lot of other similar questions. But to do that, we need to start with a simpler question and build our way up to this problem 24. So let's just do this one first. Now let's see, this is a random triangle, a scaling triangle, nothing special about this. Okay, now if I go, right, if I go parallel to this line and I separate, okay, this triangle. So I'm going to have 2 triangles, right? This one, the big one, and of course the small one. Okay, so we know that these 2 triangles are similar. Well, why? Look, if I draw a line like this, okay, so I'm pretty sure that you know, or most of you know, that this angle is equal to this angle, is equal to this angle, and equal to this angle. And we also know this angle, let me change color, this angle is equal to this angle, is equal to this angle, and is equal to this angle, right? So let's see why. So because these two, like now these 2 lines are parallel, we're going to use the same principle. Okay, this angle is equal to this angle is equal to this one, and this is common. So these 2 triangles are, okay, similar. Now, if I give you, for example, the area of this small triangle, I'm going to highlight it again. If the area of this is 10, okay, and for example, from here to here is 1, okay, and all of this side is straight, what is the area of the bigger triangle? Okay, do you know that? See, now the area of this big one, this, I'm going to highlight it by red, this bigger one, okay, you're going to take this ratio, okay, 3 to 1, okay, which is 3, and you're going to square this, okay, it's becoming 9. So the area of the big red triangle is 9 times of the area of the smaller black triangle. So this one, the big one, is actually the area of the big triangle is 90. If the inside black one is 10, then this will be 90. So in a lot of questions, like AMC questions, so they ask, for example, the area of this part, the trapezoid. It's going to be the big area, the 90 minus 10. So this area is 80. And this is like the base for a lot of questions. And even this one that we're going to do together. We're going to use this, okay, to actually answer question 24. Let's just see how. Okay, one more thing before we start. Imagine the area of this triangle is 80 units. Okay. And from here randomly, I'm gonna go and separate these two like this. So if, for example, this is 1, what do you think it is? I would say kind of like 3, right? This side is 3 times of this is smaller sides. What is the area of the smaller one? Okay, so all you have to do is divide this 80 by the sum of 1 plus 3. It will be 20. So the smaller triangle here will be 20. And this one will be 3 times of this 20. The bigger one will be 60. If we add 20 and 60, remember, this is this 80 that we already got here. So with these two principles, now problem 24 is easy to understand. Okay, now let's read problem 24. We're ready. In triangle ABC, point D divides sides AC so that AD to DC is 1 over 2. If this is 1 unit, this is 2 times of that. Okay. Let E be the midpoint of BD. So that means this line is equal to this line. This and this are equal. Okay, nice. Okay, and F be the point of intersection of line BC and line AE. Okay, not very important. Given that the area of ABC is 360, what is the area of EBF? So we're looking for this area over here. We're looking for this area. Okay, let's go and do that. So we know 360, and we're going to divide it in ratio 1 and 2. So 360 divided by 1 plus 2 is going to be 120. So what does that mean? This one is, the area of this is 120. Okay. This one. And we also know that these two parts are equal. So this is the same as this. So this line cut this 120 into 2 parts. So each of these smaller triangles, I'm going to make this by green. This one will be 60. Okay, and the other, I'm going to also make that one green. This green one will also make another 60. Okay, I think this part is simple, and almost everybody, people who try question 24, they most likely get to this part. And so this one from here to here, what is the area of that? I'm going to make it orange. The orange one will actually be 240, right? We know this much. This is doable, okay? But now from here, we need to we need to be a little creative. Remember, like my example, right? Actually, usually go back to all AMC questions. Usually question 24 is always involving similar triangle questions, right? So, and in my example, I say if you have a line, if you go parallel to this line, for example, here, then you're going to have two similar triangles. If you go parallel to this one, like this one, again, you're going to have two. So all of this will tell you draw a parallel line. See, now remember, we want to find the value of this triangle. I'm going to call it x, okay? And if I go parallel to this BF line, if I add this to here, from here to here, so let me do it. Is it black? Yes, it's black. Now you see we have two similar triangles, okay? So I'm gonna write it here with purple because these two are parallel, like this line and this line are parallel, and this one is cutting through them, right? Like the example I gave at the beginning of the question. So this is equal to this, okay? Okay. So, and this one is equal to this one. Okay. That's very good. And this one, they are in front of one another. So so all the three angles are actually equal. And one more thing, remember, we said that this line is equal to this line. Oh, I have to highlight it like this. This line is equal to this line. What does that mean? All the three angles are equal and one of the sides are equal. That means these two triangles are equal. Okay, not only the angles, but one of the sides. That means all the sides are also equal. So there you go. That means this is another x right over here. And the question is solved. The rest is just more of algebra question. So now I want you to take a look at this one. I'm going to highlight it by the red one. If that is x, then this red one will be 60 minus x. Okay. So this is 60 minus x. Very good. Okay, to remove the distractions and just clean everything else, we have the red triangle 60 minus x. Okay. This ratio over here is 1. So this is 2. This red one and the blue one, the ratio of their sides is 1 to 3. So the ratio of the areas is 1 to 3, okay? And we have to square this. So the ratio of their areas is 3 squared. The big one is 9 times of the blue one is 9 times of the red one. That's very good, okay? So I'm going to write it right over here. This one, the blue one, will be 9 times of 60 minus x. Okay, good. So now, what is this part here? The trapezoid. The blue one was 9 times. Okay. So the green one, if I remove the red one from it, will be 8 times of 60 minus x. That's very good. That's well done to us. Okay, the question is almost over. So earlier we had the area of the orange triangle was 240. And actually the area of the orange triangle and the green trapezoid, they're actually equal. Okay, focus on the green trapezoid. Focus on this part. Okay. Now if you remove this piece, this was x. Okay. If you remove this x and you bring it here, we know that this is x again. So you cut that part. Imagine you cut that x, you put it there, right? We know they are x, they're equal. So the green one becomes, okay, the orange one. So what does that mean? That means 60 minus x is equal to 240. So we got our final equation. So we're going to get 240 is equal to 480 minus 8x So we're going to have 8x is equal to 240. So the value of x will be 30. Okay. So we got it. So it was made of different stages, and I tried to make it as clear as possible. Just let me know if you found the video useful or not. Okay, good. Okay, now we got to do the last question, problem 25. And I'm going to use the stars and bars. But before I actually do, maybe some of us didn't even learn stars and bars, or some of us learned it but then we forgot, or we quite didn't understand it when the teacher taught us. Well, in all these cases, I'm going to review everything you need to understand stars and bars. And finally, we're going to use what we just learned and we're going to apply it to problem 25. So now forget problem 25 and let's learn the stars and bars and come back and do problem 25. Okay, now let's learn combinations. These letters stands for the first letter of some names. So for example, we have Ali, Bob, Celine, Danny, Ethan. Okay, and we want to choose two of these people and do something. Maybe give them rewards or punish them. It doesn't matter. We just want to select two. Okay, how many ways can we do that? But one point. Imagine we want to punish A and C, okay? Like these two people. Does it matter if I write AC or CA? No, we're gonna punish them both, right? So AC and CA are the same. We're just gonna choose two of these people. So in this case, we use combinations, right? So how many people we have? 5. How many people we want to choose? 2. Okay. So that's going to be, this is how we write combinations of 5 and 2. And how do we do this? The first number here, 5 factorial. This number, 2 factorial. And lastly, we subtract the 2. 5 minus 2 factorial. I need to make this longer. Okay. So, and then let's learn to simplify this. This is going to be 5 factorial over 2 factorial. Okay, 3 factorial here. Okay, so I'm not going to show you how. You just have to expand these. Okay, when I cancel these, okay, I explained everything. Let's go complete. So the first one is going to be, look, 5 times 4 times 3 times blah, 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 blah. 3 factorial is 3 times 2 times 1, right? Look, this part will cancel with 3 times 2 times 1. So what is left is only 5 times 4. So I could cross this and just write what is here. So I'm going to go 5 times 4. Okay, so let's clean all of this. So the numerator, the top number is 5 times 4. And 2 factorial is 1 times 2. Okay, now let's simplify. This is 20 divided by 2 is going to be 10. So there are 10 ways to choose 2 people from 5 people and bang. Okay, punish them. Okay, that's the first part. Okay, now let's go and deal with the next. Okay, now let's learn when we use the stars and bars. Okay, this is an equation. It has 3 variables. How many ways can we answer this? Infinite, unlimited, right? So for example, 1 could be 0.11. This could be, y could be 0. Random, 723. Eventually, there would be a value for z. Any numbers, infinite answers, okay? So, but if somebody tells us then x and y and z are whole numbers, they're integers, like normal numbers, the number of people, the number of apples, the number of items. We can't cut people like we have 3.5 people. We can't do that. So when we're dealing with things like this, okay, then we use the stars and bars. So to make it complete, x and y and z are all have to be more than 0, and all of them, okay, are integers. They are whole numbers, okay? These are the conditions for when we want to use the stars and bars. Okay. Now let's look. Here, I want you to imagine it like this. Instead of x, I just put a basket. Instead of y, I put a basket. Instead of z, I put another basket. And imagine these 5 are apples. So the question is like, how many ways can we put these 5 apples into these baskets? Okay, so that's the question. Like, how many ways can we put these 5 apples into these baskets? Now look. Okay. So imagine we have 5 apples, okay? And we want to divide them into these 3 baskets, okay? See, we only need 2 bars to do that. Look. Now if I put the bars, 2 bars over here, what happens? The first apples goes here, these 2 apple will go here, and these 2 apple go here. So that would be the value of x being 1, the value of y being 2, the value of z being 2 again. Okay, let's do it another one. What if I put one of my bars here and one of them here? Okay, I'll put the 2 bars like this. Then 1 apple will go here, 4 apples will go here, and here is empty, so no apple would go right over here. So then it would be z would be 5, 0, 4, and 1. Okay, so that's why we use the stars and bars, right? Now we turn the equation into a basket and apple question or a stars and bars. Okay, so just remember, when we have 3 baskets, we use 2 bars. Like baskets were the number of variables. So if I have another variable, x, y, z, and I don't know, f, for example, then 1 basket will be added here. Then I have to use 3 bars. Okay, so good. Okay, now how many ways can we just put 2 bars among 5 apples? We're gonna learn that. Okay, so how many items do we have? Right, we have 5 apples and 2 bars, so it makes like 7 items. For each of them, I'm going to draw a place. Okay, so we have 7 places. Okay, we're gonna choose 2 of these places and put the bars. So I'm going to choose this one and this one, right? These 2. So I put 1 and 1 here, like the 2 bars, and then all the apples will be here. Okay, all the apples will be forced. 5 places, 5 apples. Okay, nothing. So here, maybe I choose this place and then this place. Okay, I'll put 1 bar here, 1 bar here, and 5 apples right over here. Okay, so it's really like this now. Okay, we have 7 places and we're just gonna select 2. It's going to be combination of 7 and 2. That's the answer. Why? Remember at the beginning of the question, when I gave you 5 letters, imagine like all of these are a letter. And what did I do at the beginning of the video? I said there are 5 people and we're just gonna select 2 of them, right? 5 people, right? So now we have 7 people and you're gonna just select 2 of them. So for example, I choose B and G, right? It means I chose this place and I chose this place, right? So because I chose these places, I put the bars here and then nothing. We have 5 apples, 5 places, bang. So that's why the answer will be combination of 7 and 2, right? I want you to learn it like this. I don't want you to learn it by formula. You're not going to be able to use it well. So let me just change the question. So now if I give you 7 apples, so can you do this? Right? You could pause the video and do before you do it. Before I do it, you do it. So we're going to have 7 apples. Okay. Because we have 3 variables, we're going to need 2 bars only. Good. So count the number of items we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 items. I'm going to write it here. So how many bars do we have? 2. That's the answer. Okay, so very simple. And we could simplify it. It's going to be 9 times 8 over 2. So it's going to be 36. Now let's practice this a little more. Okay, what if we have 10 apples, and I'm going to add another variable. You pick it. F again. So now we have, you answer this question. Okay, pause the video and do it. So I'm going to clean this. I already have 7 apples, and I need 8, 9, and 10 apples. Okay, so 4 variables are like 4 baskets, right? We want to divide it into 4 parts. How many bars do I need? Only 3. Look, if I put 3 bars, now I divided them into 4 parts, each one going to each basket. Okay, so I need only 3 now. So what are the total number of items? 10 apples, 3 bars, 13. I'm going to write 13. Good. So how many of these do I have? The bars? 13 and 3. That's it. Now you have learned. Okay. There is one last thing to learn. Okay. But now what happens if I say X, Y, Z? I'm going to clean this and make this one 7. Okay. Now this will be the question again. Good. Now what happens if I say X, Y, Z are going to be larger than a 1, right? So how do we do it now? Right? We just learn it for 0. Now what if we have this condition? It's the same. Look. So we have 3 variables. We have 3 baskets. Right? Good. Now, because it says all of them are going to be at least more than 1, okay, so we just make the question easier because all of them need 1. So I'm going to just pick this one. One of the apples goes here. One of the apples go inside here. And one of the apples goes here. Okay. So good. Now, how many apples are left? Okay. I put 3 inside the basket. I have only 4. Now I need to choose and divide 4 apples into 3 baskets. Again, the same thing. I'm going to put, for example, 2 bars like this. This apple will be added to here. These 2 will be added to here. And this one will be added to here. Okay. So it asks for 3 in each basket. Instead of doing it with an empty basket, we just put 1 and now decide for these left, the 4 apples that are left. The same thing now. We have 3 variables. We have 3 baskets. We need 2 bars. Good. So let's just do it here. We have, okay, how many items? We have 6 items. How many bars? We have 2 bars. So it will be combination of 6 and 2. It will be 6 times 5 divided by 2 is going to be only 15. Okay, now it's over. Okay, you could do all similar questions. Okay, we could answer a lot of questions using this principle. Now let's go and apply what we learned on the actual question. Okay, now this question is a piece of cake. Alice has 24 apples. Okay, in how many ways can she share them with Becky, Chris? Okay, so how many baskets? We have 3 people. Okay, so imagine each person is a basket. And how many apples do we have? Like imagine we have 24. I'm not going to draw all of them, okay? So imagine all of this is 24. Now, each of the 3 people has at least 2 apples. So it's going to be like this. So from this 24, 1 goes here. Now we have 23. Okay, 22 left. 1 more to this person. 1 goes to this person. So another one and another one. How many did I give away? 6. From how many? 24. So 24, 6 gone is 18 now. Okay, so I have 18 apples left. Let me write it again. We have 18 apples. Okay, imagine this is like 18 apples. Let me write it better. We have 18 apples. And because we have, okay, 3 baskets, okay, so that means we're going to need only 2 bars. Okay, so how many items do we have in total? We have 18 apples and 2 bars. That's 20. How many bars? Just 2. There you go. So we're going to write 20 times 19 divided by 2. This one cancels. This becomes 10. Oops. So 19 times 10, 190. So, okay. This video was long, okay, because we learned, okay. Next time that you do this, if you're ready, you can answer it under a minute because now you know. Maybe you have to watch it more than once, okay, do just a little practice. But then the next time you use it, you're like, oh, rocket.